Well, good morning, everyone, and welcome to our Race to Zero webinar this morning. How can we win the race? First of all, apologies for some of the technical hitches we've had in getting started. I hope that hasn't been too difficult for you, and it doesn't interrupt now your ability to hear and see all that's going to be presented. It's a real pleasure to welcome you to the webinar, and I hope you're all going to find it really useful. Just a reminder about the rules for the webinar. If we could ask everybody to remain muted throughout, unless you're speaking, so just to avoid any interruptions. And also, if you have any questions, to put them in the chat function. And what we'll try to do is ask questions of the speakers at the end of each of their slots if there's time, or failing that, we'll have a catch up at the end of the webinar when we hopefully will have enough time to ask a few questions. As I said, the purpose of today is for members to be sharing with other members or other organizations what they're already doing to rise to the challenge of net zero. So I'm hoping that through the various presentations that you'll hear, there will be something for everybody, some tips, some ideas, things that you'll be able to pick up on and be able to take back and apply in your own organization. I'm just going to very briefly introduce the webinar, just to set a bit of background and a bit of context. So just to provide the background, there's no question that climate change is now firmly at the top of the agenda. No doubt you'll have seen some of the recent IPCC reports highlighting the severity of the challenge, one of which was entitled Code Red for Humanity, and the most recent report suggesting that global temperature rise could easily be 2 to 3 degrees centigrade or more, well above the aspirational target that COP26 is trying to address of 1.5. And I think we've all noticed the increasing frequency of extreme weather events, just as a sign of some of the changes that are starting to be physically seen in our environment. In the light of all of that, I think we can all agree that net zero is no longer something that's desirable, but it's something that's essential, and soon. And we're likely to see the timelines for significant reductions in carbon emissions being significantly shortened, with a big reduction needed by 2030, which is only 8 years away, and therefore not that far at all. And all businesses will need to have a clear net zero plan if they're going to be treated as a credible supplier or supply chain player. So what about composites and net zero? Well, I think there's no doubt that sustainability and decarbonisation is now the key existential challenge for all businesses as we address these rising climate change impacts. And composite materials are undoubtedly going to play a major role in a future net zero world because of all the benefits they bring, their durability, their lightweight strength, creating major applications in renewable energy, in transport vehicles of all sorts, and in long-lasting lightweight construction materials. So no doubt that composites are a key material of the future, and we now need all the UK value chain players to develop plans for getting to net zero, and quickly. And that's what this seminar, I hope, will be a real help to you all for. You might be wondering, well, exactly what is net zero? And why does it matter? Well, the definition of net zero is achieving a balance between the carbon emitted into the atmosphere and the carbon removed from it. It's not saying that we have to reach an absolute zero position, but we need to find a balanced position between emissions and the carbon that can be removed from the atmosphere through photosynthesis and trees and the like. And the reason it's important is that carbon dioxide in the atmosphere is now at record levels. And that's the main driver of climate change. The graph I've shown you on the bottom actually goes back across a number of millennia. You can see that carbon dioxide levels have varied over that period, but they're now at a level that's not been seen for a very, very long time. And that's why we're having the impacts that we're beginning to see. And if that increase is left unchecked, the impacts will be significant. So achieving net zero, that balance between carbon emitted and carbon removed, is really important. Some other terms that you'll have heard bandied around, and I think it's helpful to understand, what is the race to zero? Well, it's officially defined as a global campaign to rally leadership and support from businesses, cities, regions, investors for a healthy, resilient, zero carbon recovery that prevents future threats, creates decent jobs, and unlocks inclusive, sustainable growth. So there's a lot in there, but it's a global campaign to achieve a zero carbon future. You might have heard talk of SME climate commitments. And what that is about is recognizing that climate change poses a direct threat to the economy, to nature and society at large. And therefore companies are being asked to commit to take action immediately in order to halve their greenhouse gas emissions before 2030, achieve net zero emissions before 2050, and disclose progress on a yearly basis. And during the webinar today, we're going to hear a bit about disclosure, because that's going to be really important. And you may also have heard of scope 1, scope 2, scope 3 emissions. And again, you'll see this touched on in the webinar today. Scope 1 emissions are carbon emissions directly from operations that you control. Scope 2 are emissions from the generation of the energy that you use. So you may not see those emissions, but they're real. And scope 3, which is much bigger and more challenging, is all the other emissions from your value chain, both the players above you and the players lower down the value chain. Now, those definitions are going to become really well-established norms for people to be measuring against and reporting. So important that people understand what they are. And finally, just to summarize what we want to see as outputs from today. Well, the most important thing is this is about listening and learning. Listening from others who are addressing this challenge. We are all in this together, and we need to work cooperatively, and we need to learn. We need to use good practice. I would strongly encourage you to make a climate commitment, and the SME climate commitment is a good place to start. It's simple, it's clear, and it's achievable with effort. I'd encourage you to get involved. Join the Composites UK sustainability subgroup, where there are other like-minded people working together to address our challenges. And above all, get started. Every organization needs to get their plans in place and their house in order. So I hope from today, you'll be motivated and inspired to get on and get a plan in place and then start pursuing it. So without any more from me, I'm going to stop sharing. I'm going to hand over to our first speaker, who's Sophie Parsons from the National Composite Centre, who's going to talk a little bit about the measuring and reporting work they're starting to do of their own emissions.
Thanks, Malcolm. Good morning, everyone. I am just going to share my screen. There we go. Cool. Well, yes, thank you very much. So yeah, I'm going to be talking a bit about carbon accounting in general, and then yes, touching on what we're doing at NCC in this space. So Malcolm's already been through some of their definitions, so I'm not going to talk about scope 1, scope 2 and scope 3, but I think it is worth drawing attention to some of the differences between carbon neutral, net zero and absolute zero. So of course, when we're talking about carbon neutral or net zero CO2, this is where we're talking about allowing some emissions of some carbon emissions, but where those carbon emissions can then be offset elsewhere. And of course, we've got a carbon neutrality standard, the PAS 2060, for allowing us to do that. Net zero refers to same as the above, but we're dealing with all greenhouse gas emissions. Climate neutral refers to the same, but takes into account other climate aspects. And then absolute zero, which means there are no emissions produced, so we do not have any offsetting. And if you're interested in understanding more about absolute zero, I would recommend the work of Julian Allwood at Cambridge and the UK Fires programme as well, for sort of more reading around that. So talking a little bit about where sort of businesses are on their sort of net zero journey. So I've pulled some stuff out of a recent sort of BSI survey, which was conducted at the beginning of this year. So they found that over 40% of organisations had made a commitment to net zero, and manufacturing was kind of a dominant sector in terms of making some of those commitments. Within those commitments, many of them were very ambitious. So a lot of organisations had committed to reaching net zero by 2030 or 2040. And a lot of the kind of where measures were focused, looking at things like energy reduction, waste reduction, larger organisations focused on implementing sort of green energy and also more sort of general carbon reduction measures as well. In the context of Composites UK, I think it's important to note that where organisations were kind of looking for leadership after the government, they were looking at specialist association and membership bodies for more advice on this. So NCC did a big literature review of a lot of the different surveys that have gone out to businesses over the kind of past 10 years or so on net zero. Overall, we found that the sort of level of preparedness differed quite substantially between larger organisations and SMEs, which I'm sure you sort of could anticipate. Larger organisations have been sort of a little bit further ahead in terms of engaging with net zero for a little bit longer. At every organisation size, though, it was found there was a real sort of desire for more support and guidance from government. And whilst larger organisations were making progress in terms of reporting Scope 1 and Scope 2, Scope 3 was really identified as a real challenge. Supply chains are increasingly complex and global. Getting that visibility past your kind of tier 1 and tier 2 is incredibly challenging. What we found through doing a kind of big review of all the different carbon footprinting standards, and carbon footprinting standards can be sort of split between products and organisational footprinting standards. You've got ISO standards, you've got the PAS, and then you've also got the Greenhouse Gas Protocol standard as well, which also provides a separate standard for Scope 3. What we found across the board was that if we're going to be looking for footprinting in the future, which is more directly comparable between organisations, and particularly with Scope 3, we're going to need much more guidance, both in terms of Scope 1 and Scope 2. But what's really essential going forward is we generate some better guidance for Scope 3 as well. We also found that in terms of companies who are reporting, transparency and third-party verification, being clear on third-party verification and how that process was undertaken, were also kind of weaknesses as well. So going on, just to talk a little bit about how NCC are sort of supporting SMEs, particularly in this space. So we've just launched a new sustainability line walk service, which is a free site visit to help look at areas for sort of products development and manufacturing processes. We run a free sort of one-day workshop with our sustainability team as well, looking at generating new ideas, looking at existing processes, looking at how we can improve the sustainability there. We're also just about to launch introduction to sustainability training as well to upskill workforce. We also run our SME boost scheme. So if you are eligible, you are able to access up to 25k of matched funding. And that would enable you to call on us to develop whether that's life cycle assessment, whether that's doing some carbon footprinting, understanding the impact in either your business or your processes better. And we also have sort of other sort of affiliate schemes, so looking whether or not that's sort of access to other training events, member networks, that sort of thing as well. So finally, I'm going to talk a little bit about what NCC are doing for ourselves in this space. So I think it's probably fair to say we have been a little slow off the mark in terms of quantifying our own carbon footprint. Typically for many years, our carbon footprint was reported underneath the University of Bristol's, within the University of Bristol's reporting. But what we really wanted to do is look at our carbon footprint, enable us to set a baseline, which will enable us to set targets going forward. For us, this is really about having an opportunity to identify where there might be efficiency cost savings, as well as enabling us to develop a sustainability strategy and demonstrate leadership to our customers as well. So in terms of putting this together, and this is still very much in the early stages of conducting this, we worked very closely with the University of Bristol to understand kind of some of their experiences and best practice in this place. And what we found overall, that as you can see from the pie chart there, gas was the major contributor to carbon emissions. And I think it's really interesting to note, though, that although electricity is very small, this is largely to do with the fact that we have about 4% of our electricity comes from solar panels, and the rest comes from green tariff. So if you were to look at our emissions on a location basis, so using the UK electricity grid, then actually our electricity emissions would be the largest contributor to overall environmental impact. As you can see here, this has given us a really nice view of where our kind of key contributors are to environmental impact, and then this enables us to then set targets going forward for how we're going to reduce our emissions. So I'll stop there and stop sharing. I don't know if there's any time for questions.
Well, thank you very much, Sophie. No questions yet. So in the chat, just a reminder to everybody to, if you've got questions, please do ask them. Our speakers are very happy to try and answer those for you. And please do put them in the chat function, and we'll either take them at the end of each presentation, or we'll pick them up at the end as part of a final wrap up. So please do ask your questions. Don't hold back. It's a pleasure now to, well, thank you, Sophie, and to hand over now to Richard Bland, who's going to talk a little bit about the equipment that they've got for handling sustainable materials, as well as some of the actions they're taking themselves. So Richard, over to you.
Okay, thank you, Malcolm. Thank you, Sophie. And good morning, everybody. I'm Richard Bland, Managing Director here at Composite Integration, and a little bit of the work I'll talk about has been carried out by a University of Plymouth project engineer intern who's been working with us for a while. Very quickly, we're a company based down in the southwest in Saltash, near Plymouth. We're about a 35-person company, and fundamentally we're here to support companies who want to manufacture composite components. We're members of Composites UK, have been for a long time members of the National Composite Centre since its inception, and we're also involved, we're members of the Aerospace, Defence, Security and Space Society as we end up involved in a lot of the aerospace sector. So we trade internationally, we distribute in around 20 countries around the world, so we are a little bit aware of our carbon footprint with shipping as well. Our business falls into two distinct sectors, the first being the design and manufacture of equipment and tooling that companies would use in liquid resin processes in their production. Wide range of products there. The second part of our business is both commercial and collaborative funded research and technology programs. So companies can come to us with a problem and we can help solve it as long as it's within our field of liquid resin, injection, infusion, etc. We get involved in a pretty wide range of sectors, our main ones being aerospace, marine, wind and automotive. They're the big ones for us, but it is a bit of a variety. From relatively small companies right up to highly automated, large blue chips. Next slide. So, in line with a little bit of what's been discussed by Malcolm and Sophie, over the last year or so, we've been developing our company environmental, social and governance strategies. And on the environmental side, what that's meant is looking at a couple of sides to it, we're seeing quite a bit of pressure from the large blue chips. They've carried out carbon footprinting. It's a legal requirement for an amount of them. And what they've clearly identified is that their supply chain is the biggest source of their carbon emissions, which is no surprise because the supply chain is so very wide and varied. So that puts pressure onto us as SMEs to also carry out the same process. To do that, we've been working with the Future Net Zero programme, and down here in the Southwest, actually, it's incredibly helpful that SWMS, the Southwest Manufacturing Advisory Service, are a great organisation that's been helping businesses in manufacturing down here for a very long time now. And they support us with our carbon footprinting. So that's a process we're going through right now. We're working towards, as you can see at the bottom there, we work along the process of future net zero certification. And we're quite lucky if we look at our internally in our building. We refurbished this building we bought it about 2 years ago, completely refurbished. So we were able to use quite a few low energy solutions. For example, all of the lighting within the building, both in the workshops and the offices, is all LED lighting. And we've seen actually, as we've moved into this building, it's 3 times the size of our old building, but our electricity bill is actually lower. So we are seeing it's possible to make improvements. So we'll continue to work with SWMS to improve our carbon footprint internally within the building. The second side of it, looking at the sort of what we can do to help our customers with sustainability, is the world of composites and the world of materials is changing quite a bit. And over the last couple of years, new materials have come onto the market which have potential to be more sustainable in the longer term. Over the last few years, we've done quite a lot of work with, mostly with aerospace companies, on taking specific materials and understanding the requirements to process them, creating process maps, which give us repeatability and understanding of the variables that have an impact on laminate quality. So we were particularly interested to start looking at some of these materials in depth and actually work out whether the quality of the finished component was acceptable and how easy they were to process in a liquid resin environment. So a few of those materials, we surveyed the market pretty heavily, and we picked just a few to try to start with. So on the fibre side, we took woven carbon as a reference material and a pretty standard epoxy as a reference material. We're then looking at recycled carbon, woven flaxes, non-woven flaxes. And they've all been around for a while now and are probably familiar to many of you. On the resin side, the bioepoxies have come to prominence recently, and the material we looked at was a 38% organic content epoxy system. Archimedes Allium is a thermoplastic liquid resin system which has slightly interesting chemistry that it acts like a thermoset but can actually be recycled like a thermoplastic. And then recycled polyesters, which are actually 99% organic, according to the data sheets. And so we took all these materials and basically assessed them against our process map, which includes things like moisture contents, volume fraction, void contents, particularly with the materials, flow rates, viscosities, measuring all these things and actually trying to compare the materials against reference points. And that was a pretty wide range of work with quite a bit of microscopy in there and looking at final void contents, final permeabilities. Things with organic fibers, we get moisture absorption, we get resin absorption. And so some of these areas we're going to need to understand in depth to be able to advise our customers in how to use these materials and for which applications they're particularly relevant. So that work continues. There are more fibers, more resin systems to look at, but we're aiming to have that information available to our clients so that when they want to look at them, these materials, and want to use them, actually some of the background research work has been done for them. So those are the two areas. I think that's it for me. That we're looking at to try and improve our sustainability as a company. Thank you.
Thank you very much, Richard. Really interesting to hear both about what you're doing within your own factory, and great to hear that your own carbon footprint's going down, and also helping customers by looking at how different materials behave and helping them adopt a wider range of solutions. So thank you very much. Still no questions. So the invitation is there. Please do feel free to ask any question, and we'll either pick it up directly at the end of the speaker's presentation, or at the end of the webinar as a whole. So thank you, Richard, and over to our next speaker, who's Mark Thompson. He's going to tell us about the recycling of waste silicone liners, pre-preg liners that his company Techlan provides. So Mark, over to you.
Yeah, okay. Good morning. Yeah, I'm Mark Thompson. I'm the MD of Techlan, based in sunny Swansea in South Wales. And we are a circular economy business with a circular economy product. We are a bit of background. We were formed in 2009. We spent 5 years in R&D looking to develop this process. We're family owned. We have 2 directors and 6 full-time members of staff. And we're going through quite a rapid expansion at the moment. We were specifically set up just to solve the problem of waste silicone release liners generated from composite pre-preg manufacturing and laminating. Now, for those of you sort of sitting there maybe scratching your heads as to what a silicone release liner is, and you're not familiar with them, they're basically a non-stick paper and film. The easiest sort of example I can give is a sticky label. So when you remove a sticky label, the paper or the liner that's left behind is a silicone release liner, and you use these when you have, a sticky product or a sticky process, such as pre-pregging. And the recycling process is fully patented, and our recycled product that we sell, our recycled release liner, is sold under the trademark Reliner. We have 2 divisions. We have a circular division where we return waste release liners back to the original user, and we have a reliner division where we take waste release liners in and then we sell those back out into the wider industry. And I'll deal with each of those in turn. Yeah, the pre-pregging process, which you're probably very familiar with. The release liner is coated with an epoxy adhesive. This is then passed through a series of nip rollers. The fiber strands then, which are drawn in, are pressed or impregnated into the adhesive. And at the end of the process, then the release liner is removed, and this is waste material. And this often goes to landfill. It's a very, very difficult waste material to recycle, and there's a number of reasons for that. One is the silicone coating that's actually on the paper, which provides the release, makes it very difficult to repulp. And of course, there's a contaminant on the release liner as well. So it's a very difficult material to recycle, but we have a solution for that. And that's the main feedstock into our business. We've created a very innovative recycling process, and we've sort of turned recycling on its head. Now, the sort of normal way that you would look to recycle paper is that you would look to destroy it first. You destroy it, either or break it down mechanically or chemically, and use lots of energy and resources to repulp that paper and then reconstitute it into another. And in fact, every time you do that, you break down the paper fibers. But we don't do that. What we do is we take the release liner, we clean it on both sides in one pass. We use very small amounts of energy and consumables during that process. And what we end up with then is a 100% recycled release liner that still exhibits, its prime grade characteristics. We don't destroy the base paper. We don't destroy the release coating. We don't recoat. We clean the product, allowing it then to be reused. Now, an example of our circular division is with a company called GTS Flexibles in Ebbw Vale. Prior to our intervention, GTS were using their silicone release liner once, and then they were just sending it to landfill. What happens now after we've set up our circular system with them is that they use the release liner in their manufacturing process. The waste rolls that are created are then stacked onto pallets and packaged. We then send a truck in to collect the pallets and we bring them back to our site in Swansea. We then clean that product through our process. We convert it, we put good tensioning into the rolls, give bookend profile, and it's almost like a new product then going back to GTS. Now, that product at the moment, once it goes back into that cycle, we're now achieving 11 uses from the same release liner. Yeah, they're manufacturing a laminated composite, whereas they were using one release liner 11 times, using 11 different release liners. They're now using one release liner 11 times. And what's the benefit of that? And that's why we're here. It's the environmental, the reduction in the environmental impact. And GTS are achieving huge reduction in environmental impact. In fact, they're saving in excess of 80,000 kilos of carbon per year by introducing this system. And going forward into next year, although they're a rapidly expanding company, we're looking to take that from 11 uses up to a potential 15 uses, so we can improve further on those carbon savings. Not only that, of course, they've got additional savings by reduction in their landfill costs, and this system is cheaper than a prime grade liner as well. But what's really quite interesting here is, we set this up to look at carbon savings, but an added benefit of this is that with all the issues with the supply chain and through all sorts of materials globally, GTS now have become their own supplier of release liner. There's a circular system in place and they've got a lot more control of the supply into their organization. Reliner, which is our other division, we supply a 100% recycled release liner. So we take it in from Composites. We also sell back out to where it can't be reused, back into other companies, other composite manufacturers. We supply this product in reels, narrow reels, wide reels. We have over 25 different grades of release liner. And we sell back to a number of Composite UK members, companies manufacturing composite bearings, companies using heated presses for laminating, adhesive manufacturers. Again, wherever you have a sticky product or a sticky process, then we would have a reliner that could assist in that process. Again, what's the benefit? Well, reliner can 100% replace a prime grade or a new liner. Yeah, so if you're buying reliner, you get a reduction in your environmental impact, and there's a minimum carbon saving of 670 kilos per ton when you purchase reliner. So if you're consuming 10 tons of silicone release liner per year, by switching to reliner, you'd make a measurable carbon saving of a minimum of 6.7 tons. And of course, cost reduction, we have plenty of other benefits as well, but in terms of a carbon reduction, it's a very good measurable method to reduce that, to reduce it down. What have we learned during this process? What can I share with you? Circular economy, reuse of materials creates large carbon savings. Yeah, and try to think very much sort of outside the box in terms of how you approach things. Reuse over reprocess is always going to create larger carbon savings. But circular systems like this need resources. They need a lot of resources put to them in order to achieve it. So this isn't something that will be created overnight. It took us 12 months to develop the GTS system. And look at your entire supply chain. All the materials coming into your business, through your business, and out to your customers. Consider it all, because there's lots of opportunities to reuse there and reduce your carbon footprint. So yeah, that's us. You know, at any point you need any advice, or please feel free to contact me. I'll try and guide you as best I can. That's it. Great,
Mark, thank you very much. We have got a couple of questions for you. One that's in the chat from Catherine. Could you recycle the release liner after it's been processed by a composites manufacturer? I.e., will it have been cut up into smaller templates? I assume then it would have to be broken down to be remade into rolls. So
we can only process. We can only process material in real format because we reuse it. So we clean and reuse. Once the liner gets stamped or sections cut out of it, that's not reusable by Techlan.
Okay, that's great. Thank you for answering that. And there's one in the Q&A as well, which is, what is the shortest length you can process? Can you take liner which has been kitted into small pieces?
There's two things which affect the feasibility of our process. One is width and one is length. Yeah. So the sort of smallest widths that we're accepting at the moment are 330 mil wide by about 500 meters. That's the smallest width and length that we currently accept.
Okay, and one final one I think we can fit in. Is there any need to improve the base release liner to make it more fit for purpose for use as reliner?
No, there isn't. We accept all different grades of release liners, covering a very broad range of release capability and differentials. So the answer is no.
Okay, that's great. Well, thank you for those questions. Thank you very much, Mark, for a really interesting and exciting presentation, just emphasizing the value of reuse and how much of a carbon saving and a cost saving a truly circular solution can bring. So I hope that's inspired people to think about where they could perhaps try and pursue something similar. So thank you, Mark. And on to our next speaker, who's Gethin Davis from Icomat. And Gethin is going to be talking to us about some of the new hybrid materials that are available and have particular application in the transport arena. So Gethin, over to you.
Okay, thank you very much for that. Right, hopefully you should see my screen. Can you see it?
Yep, we can see it.
Great. Okay, well, thank you very much, Malcolm. Really do appreciate it. I'm going to make it a very quick and dirty one, but hopefully we'll get some questions back so we can clear things up as well. So my name's, as Malcolm mentioned, I'm Gethin Davis from Icomat. I'm going to talk to you about hybrid materials for hybrid vehicles, which is a bit of a lie, really, because it's hybrid materials for all vehicles, really, but the repetition makes for a catchier title. What we're going to go through is the current situation in the automotive industry, who Icomat are, what we do, some case studies, and then some conclusions. Now, if we were to go outside into the street today, we'll see a few cars, and they're predominantly made of steel and aluminium. There are some plastics that also play a part, like SMC tailgates, but let's be honest, it's going to be sheet metal, castings and extrusions, really. So on the top image there, you've got the Audi A8. You've got a lot of aluminium sheet metal there, a lot of extrusions and a lot of castings. And you've in the B pillar, I'm not sure if you can see my mouse there, but in the B pillar there, you've got a bit of sort of reinforced steel. And then the lower image there is the Volvo XC90, which has a lot of steel in it. It's mild steel, high strength steel, extra high strength steel, very high strength steel, ultra high strength steel as well. It's just basically a tank, and you could invade a small country with it if you really wanted to. Now, we are advancing how we use metals in the automotive industry, and the most notable example is the gigapress used by Tesla. This thing is enormous. It's huge, and I would advise you take a look at some images on Google. It's a very big casting machine, which makes a very big casting. This image on the right is the front end of a Tesla Model Y. It's made in one shot, which obviously reduces the amount of assembly processing for the vehicle then, but obviously it needs a huge amount of energy to create that casting, and it's also a huge capital investment as well. And if it wasn't for the fact that Tesla was owned by a particular billionaire, I'm not sure Tesla would be able to afford it. I may be wrong though. But what the automotive industry is looking at predominantly is ACEs. So that's autonomous vehicles, connected vehicles, because everything these days have to be connected with your phone and the internet. Also electrical vehicles, so battery electric vehicles, plug-in hybrids and hydrogen vehicles now are becoming a lot more prevalent, and also shared. In the future, we won't be buying cars to own them, we'll be sharing them and sort of requesting them, very much like an Uber today. Now, getting all these systems into a vehicle obviously has an unintended consequence, which is weight. And adding all these bits and pieces into a vehicle obviously makes it a very much heavier vehicle. And we can see that since the 1980s, vehicles have been slowly getting heavier and heavier. Yes, the real world fuel economy has also increased, as has the horsepower. But let's be perfectly honest, if we're looking at buying a new car, in the UK at least, we are very much looking at fuel efficiency, or in the case of electric vehicles, range. So the higher the range, the higher the fuel efficiency, the more attractive it is for the customer. So the heavier the vehicle, the less range and the less fuel efficiency it has, the less competitive it is. So essentially, it's in the best interest of automotive OEMs to lightweight their vehicle because it makes it more attractive to the customer. Now, obviously, I've just mentioned sort of the use of aluminium, which is a much lighter material to steel, but we are getting to the limits of what we can do with that material to a certain extent. So what can we do to lightweight the vehicle? It's potentially used to use composites, but unfortunately, the automotive industry does regard composites as being far too expensive. Or are they? This is where Icomat comes in, and Icomat has a patented rapid tow sharing technology, or RTS as it's known. We are a turnkey solution provider for the space, aerospace and the automotive sectors, and we have a technology center based in Bristol. And if you were in the the advanced engineering show last week, you'd have seen our brand new head, which does all the magic that we do. So essentially, these tapes here, we allow them to curve around, allowing you to put the tapes only where you really want them. So why is that a good thing? Well, since the 1980s, we've been looking at composites and looking at how we are laying them up. And we came to the conclusion that if we were to curve the tapes or curve the fibers to exactly where we want them to be, we would be able to reduce the amount of material used and reduce the amount of processing required as well. Now, one way of doing that would be to bend the tapes or bend the fibers. Unfortunately, the physics of this is not great. As you can see in the images here, automated fiber placement technology is rather limited by just turning the head and bending the tapes. You have a differential of the inner and the outer radius of that tape, which means you get buckling and folding of the tapes, and it basically looks like a bit of a mess. Even with very narrow tapes like 12mm wide, you get a bit of a problem. And even if you go to the 3D printing side of things as well, which uses 1mm wide tapes, whilst you have a nice area in, I'm pointing at my screen, you can't see, right? Hopefully you can see my mouse. In this area here, you have nice consolidation here, but in the radius here, you can see significant gaps, which obviously is going to be a problem when you have a part in the end. So what is different with the Icomat process, or RTS? So instead of bending the tapes, we shear them. So as you can see in the image on the left, with a 25mm wide tape, we have a nice curvature going in there. There's no delaminations. Again, with 100mm wide tape, we have a good quality layup. So we have excellent quality and high productivity because we are using wider, more cost-effective tapes. We need fewer machine passes to lay down the material. And it's also material agnostic. So you can use thermoplastic, thermosets, dry fiber, pre-preg, and also bio and more sustainable fibers as well. So I'm going to show you a bit of a bit of a video of how the machine works. And this is our development head, and it's applying, I believe it's about a 50-degree curvature to this tape. It's traveling at 0.3 meters a second. At full tilt, we can go at 1 meter a second, which is the industry standard. As I said, we can do dry fiber or pre-preg, and it's material agnostic. So what are we looking at in the automotive industry? Well, it's all very well and good laying down one tape and putting a bit of a curvature on it, but what if we put multiple tapes down and put curvatures into them, so we can apply the tapes only where it's required? We were working with an automotive OEM to lay down this bonnet, the tapes for this bonnet on the left-hand side of the screen. So this was this is where the load path is on a bonnet, and using a 30mm wide commingled tape, we created this structure then to essentially reduce the amount of materials you need to make that bonnet by not having an inner panel, not needing the assembly sort of operations for that, for applying the two sides together. We are able to reduce the amount of work needed to make that bonnet quite significantly. We expanded out even further by widening the tape using 100mm wide dry fibers with a PA6 nylon, reducing the processing time and the costs even further. And we're continuing to work with them again, and we've reduced the weight by 30% compared to a purely metallic part. By shearing the tapes in a more aggressive manner, we can reduce the machine passes down by 60% again, and also the material costs even further by 21%. And obviously this reflects then in sort of a more efficient, energy efficient production method. And it's also a very flexible, cost neutral solution. Going on to a different concept, very much, well, a different but the same. We're using unidirectional tapes with SMC, low cost SMC material. So using the £2 million pilot line that we have with one of our partners over in Ireland, we were able to lay UD tapes down in this sort of format. These
One
tapes
more minute,
then
thanks, Gethin.
I'm almost finished now. Thank you very much for that. Applying them into the SMC mold, and then we produced a one-shot part out on the right. So this enabled the manufacture of the part, and the layup time was 5 times faster and half the cost compared to AFP. And this concept can be expanded considerably to consolidate multiple parts into a single piece, therefore reducing the costs for assembly, manufacture, and also the environmental impact. So in summary, the Icomat solution is cost neutral, it's high production rate, and it's a design enabling solution. And we are looking to expand it into the automotive industry, which is a key thing well, lightweighting is a key thing for the automotive industry. And composites don't have to be expensive, they're just costed differently. The primary thing that we have a problem with is life cycle analysis and getting sort of carbon fiber into the vehicles and sort of really getting the lightweighting out of it. So any help on that front would be fantastic. Okay, thank you very much indeed.
Great, thank you, Gethin. We do have a question about 90-degree end cuts, and can it be cut at an angle? So if you've anything that you want to say in response to that.
So yes, we the new head that we just saw there, it can cut as it's going on the fly, and it can cut at any angle that you wish. Could you repeat the first part of the question, Malcolm, because I missed that.
It just says 90-degree end cuts, and then hyphen, can it be cut at can it cut at an angle?
Yes, well, yeah, it can be cut at an angle, whichever angle that you wish to have, whilst it's going on the fly. So it can be done. Okay,
that's great. Well, thank you very much, Gethin. Thanks for the question. And we will again, if there are any other questions, obviously we can pick them up at the end. Really interesting to see the way in which carbon fiber can be used, in the vehicles of the future to help in that weight-saving challenge that's clearly there.
Definitely.
On to our next speaker now, who is Alan Harper, and Alan is going to be speaking about waste, which is a kind of a key part of any road to zero has to be elimination of waste. So Alan, over to you.
Thank you very much, and thank you to the Composites UK for giving us this opportunity to share with you in a practical way of what we feel we're bringing to the industry. Basically, consumable scrap means scrap of energy. And I'm sure that a lot of you in the composites industry at this meeting will know exactly what you're looking at there. Some people say they look like dead chickens, but it's scrap from, I think in this case, a wind turbine manufacturer or boat manufacturer. But I just want to ask, well, how does this image make you feel? Do you feel good about seeing this at the end of each working day or the end of each working week, considering you're going to have to pay about £800 to have that skip removed from your site? And that is the manufacturing waste, not of the resin, but just purely the tooling. We are told, as you know, to switch to reusable shopping bags and reusable coffee cups and even straws. But surely these seem insignificant when compared to the contaminated, unrecyclable plastic waste in the composites industry. In 20 years, I'm sure you will all agree this image will not be a vision that we can accept, and it will be a vision of the past. This waste is unacceptable. But how do we get to that point? How do we bridge the gap between now and the future? Well, we can. How can we accelerate the race to zero? Basically, is what I want to share with you. And this step is accepting that we need to change. The first step is to accept that we need to change. We can no longer ignore our industry waste and thus energy footprint, because waste is energy, as we're trying to say here. So what is the solution? Well, one of them, and it's not a panacea, but it's in a lot of the cases, consumables to go to reusables. So we're going to share now, just a few moments, our small glimpse of how we are helping molders to practically change. And I might add that this is, again, not a panacea for all, but a way forward for many. So next slide, please. Okay, replacing consumables with reusables to vacuum bag composites has an outstanding reduction in the production energy demand, not just the waste. 20 kilograms from study, 20 kilograms of single-use vacuum film, whether it be nylon or whatever, the plastic, well, that's 1 square meter times 100 times, can be replaced just by 1 kilogram of reusable film, which we're talking about. The next slide, please. So vac bagging reusable membranes. 1 kilogram single-use vac bag energy to manufacture is about 26 kilowatts. And from my suppliers and looking upstream and downstream, again, for the reusable vacuum bag or film, as we call them, membranes, the energy to manufacture is 4 kilowatts. So the result of reusables are 120 times more energy efficient. That's on the basis that some of you might not follow the maths here, but I'm hiding the fact that a reusable can actually do at least 600 reuses rather than a single use. So you've got 600 times replacing. Okay, next slide, please. So reusable vac bags, the bonus you have to hit, because the numbers, you have to hit the space bar, please, whoever's controlling this. Yeah, waste required 20 times less energy to remove per kilogram. So if you're not producing the waste, and here we're suggesting that we still have a waste, but it's 20 times less energy to remove the kilogram. The next point is that no resin contamination or other multiple flow mesh and release films. This is a very, very historic statement to make. No resin contamination or other multiple flow mesh and release films. We don't have contamination in reusables any longer. So the next point I want to make is that we can they can be recycled. These blue things that you see the guy leaning against there, and that one over the truck front, after their useful life, they can be recycled into, it should say soft surface matting there, by integrating with a silicone foam. And they've also have some users have looking at for equestrian displays where they want a soft landing rather than just using sawdust in indoor equestrian. So they can be used, but there are other recycling positions for the reusables which are coming to the fore. The main thing is it's not being contaminated. The membrane is made of silicone and it hasn't got contamination in it other than changing into a harder material slightly. Next point is that we have an environmental bonus. It does not break down into microplastic, which we all know about, what happens to the plastic bags that we're using for keeping the atmosphere out of our glass fiber or carbon fiber when we're molding, either pre-preg or liquid molding. The next point is that the over-molding waste almost eliminated. In other words, we find that more and more clients using this system can reduce their overmold, the flash as it were, to a huge amount. And the final point I would like to make here is that the energy to trim and dispose is greatly reduced. In other words, if you don't produce a large amount of over mold, you're not going to have to trim it. And the cost of trimming with compressed airs and diamond tooling, etc., to trim a glass fiber around the edge to get it the right size, and then eventually to keep the dust down, you've got to have big extractors running all the time with electricity and fans, etc. And obviously, then once you've got all that waste, you've then got to dispose of it. So if you don't produce it, you save a huge amount on your wastage. The consumption of energy or need for energy. And the final point I'd like to make here is, if you can go to the next point. So we eliminate all consumables. Now, again, this is a statement which has come to the fore recently in the last 12 months. Consumables used for vacuum bagging have now been eliminated. Throwing consumables in the bin can stop. No tacky tape, no single-use bag, no flow mesh, no spiral wrap, no consumed pipes or fittings, no wasted resin catch pots, no wasted resin edge fill channels, as is the case for many light RTM applications and other applications. Though all those, from my experience of 40 years in the industry, have now disappeared and they are available. This is a practical way in which we can actually produce composite parts without the consumables. That picture on the right there is the flow mesh is in flow fields, and all those lines on that membrane are actually flow channels, but are not on the surface. They're on the backside, but they're not on the surface. They distort the surface to allow the resin to flow in what we call flow fields by going it under vacuum. And then before we fill the mold, we reverse it so they all go flat. So there's no solid lumps or runs of resin, excuse me, upon that surface. And that product there is all multi-axial fiber. There is no flow mesh or flow type of fiber in that layup, that sandwich, and that's a 20 square meter. So all of that is when the membrane is removed from the glass fiber, cured glass fiber, it is clean. It is absolutely clean. Nothing to rip off. Nothing to spend hours removing all the flow mesh and the peel ply. So those are big advantages and are practically available today. And next slide, please. And so finally, we, like Richard, we're trying to make efforts to invest in factory solar panels because my previous factory, they've got solar panels all over the place, and I've realized there's a big advantage. There's some free energy up there in the sky. and also to invest in space heating from heat pumps, because we don't use gas, we use electricity at the moment. And also I'm very happy with what Richard said, that interested to know that LEDs can help dramatically on the use of electricity in our factory. So those are what we're doing and trying to do in the race to zero. And I rest my case, gentlemen.
Great, thank you very much, Alan. As ever, a lot that you fitted in there. One question in the Q&A, I think, just really to clarify the number of times that you can reuse the membranes, just a challenge about how often they can be reused with epoxies. Could you kind of give just to make sure everyone's clear, what sort of level of reuse do you think is possible with the membranes that you're talking about here? Ester-based MMAs, phenolic, we don't have much problem above 600, 700. We have clients who've gone over 1,000. With epoxies, unfortunately, well, ACEs, they are not so favorable for this process, except in pre-preg. Pre-preg, they don't really get involved so much. But the main thing is the liquid epoxies. Unfortunately, as I say, it's not a panacea. It's available for many, but those who are using epoxies, I could promise you, we're working very furiously to bring epoxies, because the whole world and its brother that make wind turbine blades want them. Yeah, because it makes sense. Okay, brilliant. Thank you very much, Alan. Thank you, as ever, for a lot of interesting content and a lot to think about there, and how we can make sure that we drastically reduce the amount of waste and all the emissions that go with that. Exactly. So moving on to our last speaker now, who's Stephen Brown from Scott Barder, and Stephen's going to be talking about how can you measure and assess your Scope 1 and Scope 2 emissions. So Stephen, over to you.
Thanks, Malcolm. Let's make sure this presents okay. I've all this time to get it right. Can everyone see that okay?
Yeah, we can see it.
Great stuff. Okay, thanks, Malcolm. Oh, dog starts barking as soon as I start. So this is really just to hopefully make your life a bit easier than mine when I was asked to produce an ESG report for Scott Barder. So it's how I went about producing the data for our Scope 1 and Scope 2 CO2 emissions. Why should you do it? Well, depending on the size of company you are or whether or not you're listed, it's a legal requirement, and it has been for some time now. Post COP26, you'll have to also set out your plan that, for a low carbon future in line with UK's commitments. Now, if you don't know where you are, how can you plan to where you want to get to? So it's really, really important. I think it's also worth mentioning that while it might not be mandatory for your company, it could be used as a competitive advantage as more and more people try to reduce their emissions from their suppliers and customers. Then you might find it more favourable to work with a company who've actually got a good ESG report. So luckily, Malcolm and Sophie this morning have done some of this work for me, but I'll just refresh memories to what Scope 1 and Scope 2 actually are. Well, Scope 1 is direct emissions from yourself into the environment, and by yourself I mean the company. So this would be company-owned vehicles such as cars or goods vehicles. It would be gas boilers, steam compressors, emissions from coolants, refrigerants, that kind of thing. So anything that you have got complete control over. Scope 2 is emissions associated with your operations that happen within your gates. So if you purchase electricity or district steam, then there's a carbon cost associated with that. And for the purposes of being carbon neutral, this is all you have to have. For carbon neutrality, you measure your Scope 1 and Scope 2, reduce it as much as possible, and offset for the rest of the carbon. Scope 3 we mentioned earlier on. This is generally much more complex and probably a factor of 2 or 3 higher than Scope 1 and Scope 2. And it takes into account everything that's associated with your business, from your employees commuting, flights, purchase raw materials, what your customers do with your material, how it's disposed of, and that's required for net zero. Anyway, how do you do it? Because we have to learn how you actually pull together a report of this type. And the best advice I can give you is, first of all, try and understand your process. Oops, sorry, beg your pardon. So make a list of all processes in your operation where you directly control the burning of a fuel or an emission. So if it's a vehicle the company owns, if it's a vehicle the company leases, then that's your responsibility. Boilers, waste incinerators, anything whereby a liquid, gaseous, or solid fuel is used that puts emissions into the environment. So make a list of all these things. Then what to do is tabulate that data, and it's important you do tabulate it because you may wish to be audited on this information. So here's some data from Scott Bader, and I'm happy to put it there because it's in the public domain. But you know, in kilowatt hours natural gas, we had almost 17 million kilowatt hours of natural gas and 36,000 litres of oil. So you've got that in your table. You then need to convert it to units of energy because some of the reporting requirements require energy consumption as well. So this information can easily be found in conversion factors, and there's a link at the bottom to what these conversion factors are and where they can be found. Once you've done that, it's a fairly simple process to look on the same UK Gov website and use the kilowatt hours data and convert it using a conversion factor and get your greenhouse gas emissions. So far, so good. And a term that's often used here is equivalent. So here I've got ton equivalent of CO2 equivalent. And really what it is, it's an overall figure which accounts for the CO2, the methane, and the nitrogen oxide that comes from these operations. So rather than reporting on 3 greenhouse gases, you amalgamate it into 1, and this is the one most people associate with greenhouse warming. So, what about company vehicles? Because it's often not as easy. Well, I think what you want to do is, and it's worthwhile saying, anything owned by an employee is outside that scope 3. But again, before, just try and get some information. You know, try and get the total mileage through things like expense claims. If that's not feasible, then do it by self-declaration. And if people can't self-declare or they're unwilling to, or it's not easy, then perhaps look at the service interval reports when the car goes in for its annual service. But get these miles on an annualised basis. What you can then do, you can either do it the complex way and look up the values for those individual cars and convert the miles to CO2. Or what you can do is you can look up that kind of class of vehicle on the DEFRA website. They'll talk about small vehicles, medium-sized vehicles, luxury vehicles. As long as you refer to the method you used on your environmental report, it doesn't really matter too much. What you may find if you're a small company, it's easy to do it by car manufacturer and make. If it's a large company, you might want to employ a fleet management company to do this for you. But again, it's a fairly simple process as long as you have access to the data. Scope 2, indirect. Well, again, hopefully, if you're doing things really well, you'll have monitoring across your sites. You can monitor in real time or across different dates how much electricity you've used or how much steam you've actually consumed. So that's probably the best way to do that. If you don't have active measurements, then you can actually get a statement from your provider. And this is a statement from our site in Dubai. And most of the time, it actually has information on it in terms of the kilowatt hours consumed and what impact that has on the environment. So this is good data, and you can directly report this on your ESG reports. This is our UK bill, and it shows you, first of all, a much larger amount of electricity supplied to the company. But what it says here is 0 kilograms of CO2 for scope 2 emissions. Now, this is true, and what Sophie alluded to earlier on was market-based reporting. In reality, there's 2 ways to report electricity. You've got market-based and location-based, and it's actually, you're obliged to report both of them for transparency. And I'll describe what those things actually are. So the reason why you have to have 2 different types of reporting is that if you buy from a clean energy tariff, then you're essentially purchasing carbon credits, but you cannot claim that all of the electrons that come through into your building come from wind or solar or hydro. They come from the grid, and UK grid's a mixture of different things. And surprisingly, or unfortunately, a lot of it still comes from the burning of natural gas. Though there is quite a lot from wind and solar and renewables, and that's getting larger. But you have to be able to take into account the fact that it's not all green, and we don't have a decentralized grid. It's all one type. So we report on 2 different values. So how do you get those values? The same thing as before. You look at the units consumed, you look in DEFRA, and you find out the conversion factor. And back in 2020, the conversion factor for the UK grid was 0.233. So 0.233 kilograms of CO2 equivalents for every kilowatt hour of energy consumed. And that gives us a total value. So when it came to my reporting on our ESG report, I put in two figures, one for the location base, which is 0, and one for the market base, 1648. The only way you can really get 0 for market based is if you have a direct line from a solar farm or you have self-generation on your own site. If somebody was to ask me whether or not we should do that, I'd probably say, well, you could do that, but the fact of the matter is the UK grid is cleaning up its act. Sorry, I went too far. UK grid cleaning up its act, and the Tinkley point coming online, that's going to drop dramatically to about half the current levels by about 2025. So if anybody like Scott Barra, who's using a lot of natural gas, you want to improve your CO2 footprint, try and electrify things as much as possible and let the UK grid do the hard work for you. So and then in the end, it comes down to producing the report. You've got all your figures, you've got all your references to back it up, and this is how we pull it together. So I pulled together two things, as I said before, one for location-based and one for market-based, and we split them both into Scope 1 and Scope 2. And I think what you'll find is for most companies, well, certainly for Scott Badder, the Scope 1 is higher than Scope 2 because we use so much natural gas. One of the things that's often quite useful to do in these reports is actually pull together some ratios. And one of the ones which is quite good to look at and track is your energy, sort of your emission intensity. So how many kilotons of CO2 are produced per ton of product or ton of production. And it's a very good way of tracking progress against carbon neutrality or even better, net zero.
Last minute, thanks, Stephen.
Last slide, Malcolm. So the alternative is if all of this sounds too intimidating, you don't have the resource or the time to do it, the Greenhouse Gas Protocol have launched a free-to-use tool, which I've not actually used myself yet. It's in the beta stage testing, but I think it's an easier way of pulling all your stuff together and producing a compliant report. So if somebody wants to check it out, let me know how good it is, please do. And anyone interested in looking at our report for inspiration, perhaps, it can be found free to download on our website. So thanks for your attention, and I'm happy to take any questions now or in the future.
That's great. Thank you very much, Stephen. At the moment, we don't seem to have any questions. If anybody has a question, if you could put it into the the chat or the Q&A box, so excuse me, in the next minute, that would be great. Just to take advantage of all of our speakers that we have said on the webinar today. So last opportunity for questions. I'll leave it a few seconds to see if anybody quickly puts a question in. Oh, we've got one now. So a question, can a link be shared for the reporting of emissions? I don't know, Stephen, is that anything you can you speak to that?
Yes, I can. So within the presentation, there are some links. I'll ensure that I put even more links onto it for the ones that for the ones that I shared with everybody. So yeah, I'll be sure to disclose all of the different websites and utilities that I've used. No problem.
Okay, thank you, Stephen. And then another question: when will Scott Barder have the CO2 content of all their products?
I'm guessing this is one of our customers.
It is, I think, yeah.
So it's very high focus right now in Scott Barder. What we have to do, I think, first of all, is to try to scope out all of our raw materials and try to landscape where they all come from. I would probably say that for all of our products, we're probably looking into next year. If there are individual requests, I'd probably suggest throwing them through our technical service team. We may be able to provide fairly accurate, probably within about plus or minus 10% for individual products, but it's a very large exercise based upon multiple manufacturing sites and thousands of RMs. So it's not a cop-out, I'm just being completely honest, but it's certainly, I'd say Q1 next year should be a better point to answer some of these things. I'm working on it actively.
Great. Well, there we go. I think you'll have Guy from Joe Bird and Company on your case, on that timescale, looking for the data then.
And quite right.
Last chance for any questions before we bring the webinar to a close. So I'll just pause for a few seconds to see if anybody has a final question they want to put in either the Q&A box or in the chat function. Oh, one more question come through. Is there any use or value to grouping products for top level CO2 figures?
So I think it can be quite difficult because you might want to categorize something like a UPR and comment on all of those things, but I can tell you from experience that looking at the raw materials, certain raw materials have got a much higher CO2 footprint than other ones. You know, a good example is adipic acid is about 7 kilograms of CO2 per kilogram of adipic acid. Succinic acid is very similar, but it's probably got about a third of that. So it's tempting, and you might say it makes life a bit easier, but I think we should be aiming to look at things on an individual basis, because then you can see the heat map as you can see if you have to take action, because not all of these products are treated equally, I'm afraid.
Great. Well, I think at that point we will we'll bring the webinar to a close. Really just remains for me to thank each of our speakers for their very interesting and varied inputs, showing how they as individual organizations are addressing some of their own internal issues and also providing customer solutions. So on behalf of Composites UK, can I say a big thank you to our speaker panel for today. It's been really useful. And can I say a big thank you too to all those who have joined us and have contributed questions. That's what helps to often bring really useful additional information to light. So thank you for the questions. I hope you've all found it really useful, and I hope above all that you all leave the webinar feeling motivated to work within your organization to either get going on a race to zero journey or to speed it up. Because one thing for sure is that this is a topic that is only going to get bigger and bigger, and every organization is going to need to have a clear plan to be implementing it, to be reporting on it, and to be progressing it. So I hope you found it useful. We will run more events like this in future, I think. But for today, thank you very much and good luck with your plans.